Welcome everyone! I'm absolutely thrilled to share today's explainer with you. We're looking at something that is fundamentally reshaping the entire technology landscape. We're diving into the insights from Day 5 of Google's AI Agents course, which is all about spec-driven development and production AI systems. Honestly, what we're really talking about here is a massive, ground-shaking paradigm shift in software engineering. I mean, for decades, the tech world has operated under one core assumption. Humans write the code, and the more code you can write, the more valuable you are. But what happens when that completely flips?
It's a total mindset shift. For the longest time, software engineers were judged by how many lines of code they could punch out in a day. It was literally the metric of productivity. But right now, today, AI coding assistants can generate thousands of lines of code in the blink of an eye. The traditional bottleneck, actually sitting there typing out the syntax, has been completely blown wide open. So if an AI can write software faster and honestly often more accurately than a human, where does that leave us? What becomes the developer's actual job?
Okay, let's dive right into this with Section 1, the blueprint analogy. To really understand how we need to work with AI moving forward, imagine asking a construction crew to build your dream house with just one instruction: build me a house. They'd have to guess everything, right? And that's going to result in a ton of mistakes. In the software world, doing this with AI is called vibe coding, which is essentially just guessing your way through with a vague prompt. Now contrast that with spec-driven development. This is when you hand that same builder a highly detailed, precise architectural blueprint, allowing them to construct the house confidently and flawlessly from day one.
So, what does this all mean for us? Well, a specification isn't just some basic idea you jot down. It's a meticulously detailed description of exactly what should be built, and crucially, what success actually looks like. Instead of letting an AI just stumble around in the dark trying to guess its way through the development process, a specification gives the AI a brilliantly clear destination. It sets up the rules, the flow, and the exact requirements before a single line of code is ever generated.
Moving right along to Section 2, why code is disposable.
Now, I know the idea of disposable code sounds absolutely crazy to anyone who spent months writing a program. But because AI can generate code instantly, code itself just isn't the precious, scarce resource it used to be. If your software breaks, or if you need to completely pivot your product, you don't necessarily have to spend weeks painstakingly rewriting everything. The AI can recreate it again and again almost instantly. Because code is now so cheap and essentially disposable, the true power, the real undeniable value, shifts entirely to the blueprint itself. The system design is where the magic actually happens.
And this brilliantly illustrates exactly how this system design works in practice. Let's look at a real-world example of a product research workflow. If you're just vibe coding, you might tell the AI, hey, build me a product research app. Yeah, good luck with that. But with a solid specification, you break it down into explicit steps. Step 1, the user uploads a product. Step 2, the system runs a demand and competition analysis. Step 3, it generates a final report. Do you see the difference there? You're giving the AI a step-by-step GPS route. It knows exactly where it's starting, the path it needs to take, and exactly what that final destination looks like.
Which brings us to Section 3, connecting AI systems together.
To execute these complex blueprints we've been talking about, different intelligent tools actually need to talk to each other. And to make these workflows happen, we rely on a concept called MCP. Think of MCP simply as a universal USB port for AI systems. Just like you can plug almost any device into your computer's USB port and it just works, MCP allows all these different, highly specialized AI agents and external tools to plug right into standard interfaces. It's the universal connector that brings your entire blueprint to life, letting different systems seamlessly pass information back and forth.
Let's move to Section 4 and see how this builds into setting safe AI guardrails.
When you've got AI systems generating massive amounts of code at lightning speed, applying old, slow human review processes creates a really dangerous bottleneck. We call this review overload. Think about it. An AI can write 10,000 lines of code in minutes. A human developer physically cannot read and comprehend that code at the same speed. They become completely overwhelmed by the sheer volume of changes. And what happens when a human is bombarded with hundreds of approval requests? They get approval fatigue. They get tired, frustrated, and eventually they just start blindly clicking approve without actually paying attention to what the AI is doing. And honestly, that's a recipe for disaster.
The source material shares a very sobering story about this exact issue. There was an incident where an AI system was integrated into a company's workflow, and due to a lack of oversight, it ended up sending out real emails to users containing completely incorrect information. It just fired them off. Now, the lesson here isn't that AI is bad. It's that AI needs supervision. It's an incredibly powerful engine, for sure,
but a powerful engine without a steering wheel or brakes is just a hazard waiting to happen.
Now, what's really interesting about this is how we establish those necessary boundaries to keep these powerful systems safely on track. We have the 4 pillars of AI guardrails. First, sandboxing, giving the AI a safe, protected digital playground to experiment in where it absolutely can't break the real system. Second, human in the loop, ensuring a real person is always there to approve those high-stakes actions. Third, policy servers. And fourth, context hygiene. Let's look a little closer at those last 2.
A policy server is absolutely essential here. Think of it as a strict security guard standing right at the door of your application. Before the AI is allowed to execute any important action, like deleting a file, making a payment, or sending out an email, the policy server steps in. It verifies the AI's permissions, double-checks the company rules, and ensures everything is completely safe before giving the green light. Basically, it stops the AI from going rogue.
And then we have context hygiene. This is absolutely crucial for fiercely protecting user privacy. An AI does not need to see your customer's social security numbers or private passwords just to write a sorting algorithm, right? Context hygiene means we hide that private data behind secure placeholders. The AI only sees the absolute minimum information necessary to do its job. This not only protects sensitive data, but it actually reduces the chances of the AI getting confused and making mistakes.
And finally, we arrive at Section 5, the architect of the future.
So the crucial point is this: if AI is doing the heavy lifting of writing the code, what exactly does the human being do? Well, the human developer transforms from a mere typist of syntax into a grand designer. The future developer becomes an architect. You are the one sketching out the master plan, deciding exactly what the software should achieve and how all the different pieces fit together into a cohesive whole.
But it doesn't stop there. You also become a strategist. You're no longer just staring at one single function. You're planning massive, complex workflows. You're mapping out exactly how different AI agents will collaborate, pass tasks to one another, and solve large-scale problems efficiently. You're playing chess now, not checkers.
You also take on the critical role of the reviewer. Remember that human-in-the-loop guardrail we just talked about? Well, that's you. Your expertise is desperately needed to evaluate the AI's outputs, catch those subtle logical errors that a machine might miss, and course-correct the system when it starts to drift off its GPS route. Your human judgment becomes your greatest asset.
Ultimately, you become a guide. You oversee a massive, bustling ecosystem of intelligent tools. You aren't down in the trenches digging the dirt anymore. You're standing up on the hill, directing the heavy machinery, ensuring everything operates smoothly, safely, and achieves the exact vision you set out in your blueprint.
Which leaves us with this final, incredibly powerful thought from the course material. The future is not about writing more code, it's about designing better systems. The automation of coding isn't the end of software engineering at all. It's just an incredible evolution. It frees us from the tedious work so we can focus on what humans do best: imagining, planning, and creating. So I'll leave you with this question to ponder today. If you never had to write a single line of code again, what kind of amazing systems would you choose to build? Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.